All right, let's dive in. So today's topic is converting between bases. What that means is we're going to be given a number in base 10 and convert it to a different base. And also, we're going to be given a number in a different base and convert that to base 10. So that's really all we're going to talk about today. It's going back and forth between base 10 and other bases. I don't think you'll find the processes to be overly complex, but we want to be patient and careful as we go through those, especially when we go the direction where we're starting with base 10 and going to a different base. We definitely want to be patient and careful as we do those. That's the more challenging of the two. All right, just a little reminder to start with of expanded form. Expanded form was something that we saw last week. It was a way to write out a number. Remember, when we talk about the base 10 system, what we're talking about there is place values that are built around base 10. We have 10 to the 0. That's our ones column. Next to that, we'll have 10 to the first. That's 10 raised to the first power. That's our tens column. Next to that, we have 10 raised to the second. 10 squared, that's 100. And next to that, we would have 10 to the third power. 10 times 10 times 10, that's 1,000. And that's where we get our place value positions in the base 10 system. And that's true in the other bases also. The key here is, as we write these numbers with a base and an exponent, the base every single time is 10. And that's why it's called a base 10 system. It's because our place values are based on powers of 10. If we wanted to write the number 236 in expanded form, we're going to use that base 10 notation to do it. We have 2 in the hundreds column. So that's 2 times 10 to the second plus 3 in the tens position. So that's 3 times 10 to the first. And then finally 6 times 10 to the 0. Essentially, what this number really says is we have 2 100s, we have 3 10s, and we have 6 1s. Are there any questions on expanded form, where those place value positions came from, how base 10 is structured, built around those place value positions? Rewriting 236 in expanded form. Are there any questions about any of that before we go forward to look at a different base? All right. Based on the quiz performance last week, I believe you. All right. So let's talk a little bit about base 8. And there's nothing magical about base 8. I could have used base 4 or base 7 or base 9. It doesn't matter. We're just, base 8's the one we're going to use to sort of discuss this a little bit. And if we look at base 8, it's going to have place value positions. And the first of those is going to be 8 raised to the 0 power. Anything raised to the 0 power is 1. So we're going to have a ones column. Moving over, we'll have 8 raised to the first power. 8 raised to the first, that's 8. Moving over again, we'll have 8 raised to the second power. That's going to be 8 times 8 is 64. So in the base 8 place value system, we don't have ones, tens, and hundreds. Instead, we have ones, 8s, 64s. And we can keep going with whatever 8 to the third is. But the idea here is, instead of ones, tens, and hundreds, because it's base 8, we have 1s, 8s, and 64s. You let me know if you see anything that feels like it's out of nowhere, is challenging, or you don't understand what's happening. The idea that we have place values that are 1s, 8s, and 64s, that can be a little strange, and that's all right. But if you're really not sure where the 1, 8, or 64 came from, that's something we want to make sure we address. A minute ago, we wrote the number 236 in expanded form for base 10. Well, what happens if we wanted to write the number 236 in expanded form for base 8. So if I wanted to write 236, or excuse me, 236 in expanded form in base 8, what we would do then is we would say, well, I've got to look at my place value positions. Here, I have 8 to the second power. Here, I have 8 to the first power, and here I have 8 to the 0 power. So in expanded form, this would be 2 times 8 to the second plus 3 times 8 to the first plus 6 times 8 to the 0. Before I go forward, I want to give you a chance to ask any questions about that. Because we're in base 8, now we have 64s, 8s, and 1s. What that number means, that 236, what it means is we have 2 64s, 3 8s, and 6 1s. It's all right for that to feel a little strange as long as you're understanding where everything's coming from. So I've written 236 in base 8 in expanded form. This right here would be 236 written in expanded form. Is that okay? I get a sense that it is. If our job here was to convert convert 236 base 8 to base 10. This is exactly how we would do that. If we were asked to convert 236 base 8 to base 10, what we're going to do is we're going to write 236 in expanded form, and then we're going to simplify. So we would have, let's see, we've got to do exponents first. So this would be 2 times 64 plus 3 times 8 plus 6 times 1. And essentially all we're saying there is, because it's base 8, the way the place value system works is I have 2 64s, 3 8s, and 6 1s. Now we'll keep going with our simplifying. 2 times 64 would be 128. 3 times 8 is 24. 6 times 1 is 6. And then we'll add all that together. 128 plus 24 plus 6 is 158. What we started out with was 236 in base 8. We just found out that that's equivalent to 158 in base 10. And I should put a little 10 down there just to emphasize that it's base 10. So 236 in base 8 converted to base 10 would be 158. These two things have the exact same value. 236 base 8 and 158 base 10 have the exact same value. So make sure that makes sense. What we're saying is 2 64s plus 3 8s plus 6 1s has the same value as 100, 5 10s, and 8 1s. We're saying those two things have the same value. They do. So if we want to convert a number that's not base 10 into base 10, the way we're going to do that is we're going to write it in expanded form and then simplify. Are there any questions about that before I have you try one? Fantastic, here goes. What? That's the one I just did. How about you do this one? Convert 5/7 base 8 to base 10. That's funny. Thanks, Nicole. I appreciate that. I guess originally I was going to do it on a new slide and I got carried away and did it on that one. So convert 5/7 base 8 to base 10. I'll make a poll for this one and we'll see how it goes. And essentially what we're looking for here is what is the equivalent of 5, 7 base 8 if we were to write it in base 10. And what we're going to do here is we're going to use expanded form to help us get there. We don't have to be in a hurry at all today. Going back and forth between the bases is something that I don't think the computations are very challenging, but I want to make sure that it makes sense. So we don't have a whole lot to cover in our lesson today. We're going to go from other bases to base 10, and then from base 10 to other bases. Once we can do that, that's what we're after today, and that's what the assigned problems will be about, is just practicing those ideas, going back and forth between base 10 and other bases. We'll go another 30 seconds and then talk about this one. All right, let's see where we are. Not unanimous, but strong agreement. As we go through this, if you have questions you want to ask, or you see something that you're not sure of or doesn't make sense, just let me know. So we're converting 5, 7 base 8 into base 10. Once we see that this is base 8, that lets us know that our place value positions are going to be 8 to the 0, which is the ones place, 8 to the first, which is the 8's place, and then 8 to the second, which would be the 64's place. Now, the number we were given only has 2 place value positions used, so we're going to use the 8's and the 1's. And so written out in expanded form here, what I have is I have 5 times 8 to the first power and 7 times 8 to the 0 power. Some of you who are really comfortable with this might immediately look at this and say, well, it's base 8. So I have a 1's column and I have an 8's column. So really, this is just 5 8's and 7 1's. Perfect. Great. If you're that comfortable, you can skip this sort of specific expanded form column if you want to. If you're comfortable and you're confident and you're getting things right and you look at this and you see, well, it's base 8, so that means I have 1's and 8's, you could go straight to here. That'd be just fine. Because essentially what we're after is our final number, which 5 times 8 is 40. 7 times 1 is 7. We'll add those together and get 47. And because this is a base 10 number, it really is 47. This one up here, the one that we started with, that's 5, 7, base 8. But this one we can actually say 47. And what we're saying there is that 5, 7, base 8 is the same thing as 47 base 10. What we're saying is 5 8's and 7 1's is the same as 4 10's and 7 1's. Hopefully all that makes sense and is reasonably comfortable. Practice makes it better. But if there are any questions you have, go ahead and let me know. Now's a great time. I'll have you practice another one here in just a second. All right, let's try another one. Convert 213 base 4 to base 10. I'll set up a poll for this one too. base 4, a little bit different. First thing we have to do is establish our place value positions and then go from there. We'll go another 30 seconds on this, and then we'll talk about it. Okay, very good. Very good. Not unanimous, but pretty close. All right, let's see where we are with this one. Convert 213 base 4 to base 10. All right, well, once we see that this is base 4, that means our place values are going to be 4 to the 0, 4 to the 1, 4 to the 2, and that's all we need. We only have 3 place value positions in our number over here, so that'll do it. So we're going to have 1s, we're going to have 4s, and then 4 squared, we're going to have 16s. So we have 1s, 4s, and 16s are our place value positions. And then when I go to write this down, I'm going to have, well, I have 2 4 to the seconds plus 1 4 to the first plus 3 4 to the 0. Or I have 2 16s plus 1 4 plus 3 1s. And that's because our place value positions are 1s, 4s, 16s. So I have 2 16s, 1 4, and 3 1s. That's what that number represents. Now I just need to simplify. 2 times 16 is 32, plus 1 times 4 is 4, plus 3 times 1 is 3. 32 plus 4 plus 3 is 39. And what we're saying then is 39 base 10 is the same as 213 base 4. Those two are the same as each other. The pulls have gone great, but please let me know if you have any questions. To go from another base to base 10, that's what we're doing here, is going to base 10. Essentially what we need to do is rewrite it in expanded form and then simplify. Okay, that's going to base 10. Now let's talk about going the other direction, converting from base 10. For example, if we want to convert 66 to base 5, this is a little more complicated than the other way, but honestly, a lot of the ideas are the same. we're going to convert 66 to base 5. Just like we did before, we want to know what those place value positions are going to be. In base 5, that's going to be 5 to the 0, which will be the ones place. Then we'll have 5 to the first power, which will be the fives place. Then we'll have 5 to the second power, which is the 25s place. And then we'll go 5 to the third power, which I don't know what that is. Let's see. 5 times 5 times 5 is 125. What we're going to do when we convert 66 to a base 5 number is we're going to figure out how many of each of these are we going to need. My first question to you is this. How many 125s are we going to need to write the number 66? Okay, so if we have 125 and we don't have anything else, we're already at 125, which is too big. So we won't need any of those. And that's part of the reason I went that far. Yes, Nicole, good. Emily, great. One of the things you'll do when you're trying to figure out how to convert a number into a base other than 10. Great, Nicole. 25s is the highest we're going to need. Is you kind of figure out, okay, I might need ones, I might need fives, I might need 25s. What's the next one over? 5 to the third would be 125. Well, the number I'm converting is 66. So once I find a place where, hey, this number is bigger than what I need, I'm not going to need those at all. That's how you know when to stop. When you're thinking, what place value positions in base 5 am I going to need here? Well, I might need ones, I might need fives, I might need 25s. I'm not going to need any of these though, because that's bigger than the number I'm trying to convert. And so that's how you know when you've reached the end of the line. These are the only place value positions that are even possible in this question. And then we start figuring it out from the top down. We'll get there, Nicole. I appreciate that you dove right in. I think that's awesome. But hang on, and we're going to get there to see if that's where we do end up and how we get there. So the first thing we're going to do, we're not going to write this in expanded form because, we've got this base 10 number. So writing it in expanded form is not going to do us any good. What we are going to do, though, now that I know the place value positions that I might use, is I'm going to start at the biggest of those and figure out how many 25s will go into 66. Our first question is, how many 25s do we need? There's a couple of ways you can do this with a relatively small number like this. You could probably do it in your head. How many 25s are we going to need to get to 66? And I guess my real question is, what's the biggest number of 25s possible that could go into 66? Perfect, Leslie. Perfect, Moylan. Emily, great. 2. And you could say, well, I'm going to do 66 divided by 25. And when I do that, I get 2.64. We don't care at all about the 0.64 part. What we do care about, though, is the 2. So we're going to have 2 25s in our answer. We know that for sure. We're going to have a 2 in the 25s place. And then we have to think, okay, if I have 2 25s, how much of this number have I taken care of so far? And I realize that's a weird way to phrase this, but I don't know a better way to phrase it. I'm trying to build the number 66. Right now I have 2 25s. Excellent, Leslie, Nicole, perfect. I have 2 25s, so far I have 50. I'm trying to build the number 66. So far I have 2 25s, that's 50. And so I still need to keep building. How much do I have left that I need to keep building? I started with 66. I've taken care of 50 of it. How much is left? Excellent. Very good. Leslie, Jessica, perfect. So that's right. So I'll do 66 minus 50 and see that I have 16 left to go. And now I'm just going to repeat that process over again. Now I move over to the fives place and I ask myself, to get to this 16, how many fives will it take to get to 16? When the numbers get small, you can probably do it in your head, but you don't have to. You can actually divide. How many fives am I going to need? Three. Three. Very good. Outstanding. This is terrific. So I'm going to need 3 fives, and that's because if I did 16 divided by 5, I get 3 point something. I don't even really care what the something is. What matters to me is that 3 right there. That 3 is important because now I'm going to have 3 fives. And then I have to figure out what I have left. I'm going to do the same thing again that I did before. These 3 fives took care of 15. I was at 16. I just took care of 15. So what's left for me to throw in the ones place? One. Excellent. I'll do 16 minus 15 and see that I have 1 left. And that 1 is going to go in the ones place. And so, Nicole, a long time ago when you said 2, 3, 1 base 5, you were exactly right. 2, 3, 1 base 5. And what we did there is we figured out, okay, how many 25s do I need? What does that take care of? How many 5s do I need? What does that take care of? And how many ones do I need to finish it off? One thing that's sort of a self-check that's built in here is we're in base 5. So the only numbers we have to work with are 0, 1, 2, 3, 4. If you get anything over here that is anything other than 0, 1, 2, 3, 4, it can't be right. Because in base 5, these are the only numbers we have to work with. Sometimes when I talk about going back and forth between bases, what you might hear me say is when we're going to base 10, we multiply and add. And when we're going from base 10, we divide and subtract. And so if you hear those, that's exactly what I'm talking about, the processes we use. When we're going to base 10, we write it in expanded form and we multiply and add to get to our answer. When we're going from base 10, we figure out our place values and figure out how we're going to build that number 66. And in this case, instead of multiply and add, now we're going to divide and then subtract to see how much is left. Let's try a couple of these. Convert 27, or excuse me, 27, convert 27 to base 4. Convert 27 to base 4. Remember, we're in base 4, so figure out what our place values positions are going to be, and then go from there. You don't see the answer over there. Let me retype those answers. I was looking at the wrong line on my page. Try that again. We'll go another 30 seconds on this one. Maybe I'll give you a little longer. Yeah, let's go a little longer. Since I typed the wrong numbers in there to start with. All right, now let's go another 15 seconds and then do this one together. Okay. Not unanimous, but definitely strong agreement. Let's take a look at this one. Convert 27 to base 4. All right, so the first thing we'll do is we'll go, okay, I'm trying to put this in base 4. So I'm going to have 4 to the 0, which will be the 1's place. I'll have 4 to the first, which will be the 4's place. I'll have 4 to the second, which will be the 16's place. That's probably all I need, but just to make sure, if I check 4 to the third, 4 times 4 times 4, that's 64. Well, I'm not going to need any 64s to get to 27. So I don't need that column. So I know those are the columns that are in play for me. When I do that, let's see. Starting out with 27, and the question is, how many 16s? You may reason that out, or you may say, well, if I do 27 divided by 16, I get 1 point something. The something doesn't matter. I just know I need 1 16. So I need 1 16. All right. And then what I've done so far is I started with 27. I've accounted for 16 of that number so I can subtract it. And that leaves me with 11. Now I have 11 I have to take care of. I need to account for. And I'm over in my 4's column now. And so the question is, how many 4's? And so I can do 11 divided by 4. And when I do that, I get 2 point something. The something doesn't matter, but the 2 does. So I know I'm going to have a 2 in the 4's column. And that's going to take care of, let's see, 2 times 4 is going to take care of 8. So I had 11 to deal with. I've gotten rid of 8 of them. So I have 3 remaining, and those 3 are just going to go in the 1's place. So 27 converted to a base 4 number is 1, 2, 3, base 4. Remember what we're saying when we do a conversion like this. What we're saying is that 2 10s and 7 1s, that's a 1. How about we make it a 1? 2 10s and 7 1s is the same as 1 16, 2 4s, and 3 1s. That's what we're saying is those two are equivalent to each other when we convert between bases. Are there questions on that before I have you try one more? Awesome. Very good. Okay. Convert 159 to base 7. So 159 to base 7. We'll do a poll for this one too. I don't think we've done base 7 yet today, so this is a good one for us to do. We'll go another 30 seconds on this and then we'll talk through it. See where we are? Outstanding. Unanimous. I think we've got it. That's great news. All right, let's talk through it just to be sure. If you see anything that you're unsure about, you let me know. We have 159 that we need to convert to base 7. Once we see that that's base 7, we're going to have 7 to the 0, which will be 1s, 7 to the first, which is 7s, 7 to the second, which is 49s, and 7 to the third if we need them. Let's see, 7 times 7 times 7, 343. Well, the number we're working towards is 159, so we're not going to need any 343s. So our first question is, how many 49s? Now this one I can't really do in my head, so here I'm really going to divide it. 159 divided by 49. And that's 3 point something. Something doesn't matter, but the 3 does. So we know we're going to start out with a 3 in the 49's place. And this is going to account for 3 times 49, or let's see, 147 of our number. We're trying to build 159. We've got 147 of it already. So we'll do 159 minus 147, and we still have 12 that we need to build. You may be able to do it from here. Some of you who are really comfortable and confident with this right now will go, well, to get to 12, I guess all I really need to get to 12 is a 7 and 5 ones. If you're there, that's outstanding. If you're not, it's totally fine. The next question we'll ask ourselves as we look at this and move over to the 7's column is how many 7s? How many 7s will go into 12? And you could do 12 divided by 7 and get 1 point something. And we don't care about the something, but we do care about the 1. And so we're going to put a 1 in the 7's place. And that's going to take care of, well, 1 times 7, that takes care of 7. I had 12 that I needed to account for. I just took care of 7 of those, so I have 5 left. And those 5 are going to go in the 1's place. So 159, when converted to base 7, is 315. And remember, what we're saying there is that 100, 5 10s, and 9 1s has the same value as 3 49s, 1 7, and 5 1s.